So let's pretend today has rolled around and I really don't want to teach you anything. So I just want to keep you busy. So I come up with this great idea and I say add up the first 500 positive integers. So many of you start writing 1 plus 2 plus 3 plus 4 plus ... up to 500. And you start taking your calculator and you start punching those in one at a time. 1 plus 2 plus 3. And it's very busy work, very tedious. But that's okay. I just wanted to keep you busy. Well, for those of us that are learned and rather observant, we might find a quicker way to do this. What we might notice is that if we take 1 plus 500, that's 501. If I take 2 plus 499, that's 501. If I take 3 plus 498, guess what that is? Oh, it's 501. And then you might realize, well, there's 500 numbers. That means that there's going to be 250 of these 501 sums, and we can multiply those together, and we are done. And it's very quick. You come up to me and you say, Mr. Schnack, I'm done. And you say, no, you're not done. Go back. You got like 20 minutes left before you can possibly be done with this, but you're done. And what you noticed is that there's a nice quick pattern to finding this sum, to adding this series, and it's because this series is one of these beautiful arithmetic ones. Arithmetic series are very quick to evaluate because of this nice pattern they have. They have a nice rule. They have a nice rule for finding the sum. Our sum, what we did here was we took the first term and the last term, a1 plus an, and then we multiplied that by the number of terms divided by 2. And that gave us the sum of the first n terms. We call this a partial sum because we're adding up a finite number of terms. So n divided by 2 times a1 plus an. This is in your IB formula pack. There's a manipulation of this where if we don't know what the last term we're adding up is, and all we know is the first term and the common difference, we can use those. So let's look at what we could replace this with. That's a1 plus n minus 1 times d. That's our basic arithmetic sequence rule. So n divided by 2. If we make this substitution, now the rule for the sum becomes n divided by 2 times 2a1 plus n minus 1 times d. And guess what, ladies and gentlemen? This formula, it's also in your IB formula pack. So now that we've got the formulas out of the way, let's try and tackle a couple examples. So I want to find the sum of the first 30 terms, so n is 30, of an arithmetic progression with first term 8 and common difference of 0.5. Now, there's two ways that we could approach this. We could either use the green formula or the black formula. We know the first term and common difference. I could just drop it directly in here. I'm actually going to use the green one just to be different. I'm a different kind of guy. So if I'm adding the first 30 terms, that means I need S30, that's what I'm finding, equals 30 divided by 2 times first term plus A30. Well, one way that I could do this, besides just using that nice rule on the previous slide, is A30 would be 8 plus 30 minus 1 times 0.5. I can use my arithmetic sequence rule because this is an arithmetic progression. So 8 plus 29 times 0.5. And we can take that and we can plug it in right here for our A30. So S30, if we do it that way, we will get the exact same thing as if I would have done 30 over 2 times 8 plus 29 times 0.5. That's the second formula, 2 times A1 plus n minus 1 times D. Crunching these numbers, we get that the sum of these 30 terms is 457.5, regardless of which formula we're using, the green one or the black one. We have to use the arithmetic sequence rule. It's just whether or not we're using it on our own or if we have it built into the formula already. Second example, find the sum of all the multiples of 3 between 100 and 1,000. Well, first we need to know really what's going on here. What is this series that we need to find? Well, what's the first multiple of 3? Is 100? No, 100 is not divisible by 3. Is 101? Well, if you're not sure, there's a trick for telling if a number is divisible by 3. Add the digits. If that sum is divisible by 3, so is our number. So is 101? Well, 1 plus 0 plus 1 is 2. 2 is not divisible by 3. Is 102 divisible by 3? 1 plus 0 plus 2 is 3. 3 is divisible by 3. Therefore, 102 is divisible by 3, and it is the first term of my series. 102 plus, well, the next one would be 3 numbers away. 105 plus, 108 plus, dot, 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 all the way up to what's the biggest multiple of 3 that is 1,000 or less? Well, it's 999. So this sum, we need n. Well, okay, how do we find n? Well, we're going to deal with this term right there. We are going to use our arithmetic rule. 999 equals first term, well, that's 102, plus n minus 1 times d. Well, what's d? d is 3, ladies and gentlemen. Now we can solve this bad boy for n. I'm going to subtract my 102. We get 897 equals n minus 1 times 3. I would divide by 3 here and then add my 1. $897 divided by 3, that's going to be 299. We add the 1, n is 300. So that means that there are 300 multiples of 3 in between 100 and 1,000. So S sub 300 is equal to 300 over 2 times first term plus last term. Here's an instance where we're using that first formula that I listed for you. And this sum, it's a big number. 165,150. There we have it. Last example for today. An arithmetic sequence has a first term of 5 and a common difference of 10. If the sum of all the terms is 720, how many terms are in the sequence? Here's an opportunity to use our second rule again, because we have the first term and we have the common difference. So S sub n, we don't know n. So we're going to write n divided by 2, and 2 times first term, so 2 times 5, plus n minus 1, we still don't know n, times 10. Now we simplify and we solve. And this sum, this S sub n, this is equal to 720. I suppose that's a very important piece of information for us. Here we go. N divided by 2, 10, that's 2 times 5, and then distribute. 10n minus 10 equals 720. Well, 10 minus 10 is 0. I'm just simplifying now. N over 2, negative 10n equals, it would be positive 10n, my apologies, equals 720. Multiply these together, we get 5n squared equals 720. Divide by 5n squared, is 144. Now here's something to remember. This is the number of terms in a sequence. N can only be a positive integer. So this better be a perfect square. And lo and behold, it is. Normally we write n equals plus or minus 12, but because it has to be a positive integer, we know that we added up 12 terms to get that sum of 720. So please notice that in all three of these examples, we did end up utilizing some form of that arithmetic rule that a1 plus n minus 1 times d. This purple pinkish formula just has that built into it right here. So that's where we stopped today. I hope you had as much fun as I did, and I will see you later.